you can see, we've got some really high-tech Northwestern physics equipment here tonight. No, it looks fun. And let me introduce the speakers, our presenters, I guess you should say. This one behind me is Art Schmidt, and he's a distinguished senior lecturer in the Department of Physics and Astronomy at Northwestern. He started his career teaching for 6 years at Lake Forest College, and then he came to Northwestern in 1984. Since his arrival at Northwestern, he has received the Distinguished Teacher Award from the School of Continuing Studies in 1999, and then in 2000 he received from the Weinberg College of Arts and Sciences the Alumni Teaching Award. And as lecturer, demonstrator for the department and director of the undergraduate laboratory, am I reverberating? Oh, that's Art has had a lot of fun demonstrating the physics in toys to his students, which that sounds a lot like what we're going to be doing tonight. And this fellow over here is Tom Sr. in the yellow t-shirt. He's a retired high school physics teacher from Prairie. And he was recently hired as a physics instructional resource agent under a special grant to classify and publicize the Northwestern University undergraduate physics lecture demonstration collection. He has received a Distinguished Service Award from the American Association of Physics Teachers for his contributions to physics education, and that was last year. So we're happy to have them both with us tonight. I think it's going to be really fun and something kind of a little bit different.
There are also little pieces of finely cut paper towel you'll find in the middle of your table.
Sure.
You want to wet them in your beer or drink or whatever's convenient. So you have a slightly damp paper towel, you wrap it around the string.
Sophisticated for Northwestern, and that is this is what it's called hockey tape. And when the tape has ridges in it, and the ridges will cause the cup to vibrate when you run your thumb across the ridges. This is soap. This is actually a magic mixture. It is 1/3 joy. You're not blowing that bubble up. Why is it not blowing the bubble up? It turns out the energy of sound passes through air, so the air does not pass. Just the energy of the sound.
Since sound is a wave, and we can make waves on a spring, we're going to show you a thing called standing wave. The standing wave is made by the wave bouncing back and forth and doing that interference with itself. In other words, an up wave and a down wave will cancel out. So, now, watch what happens to this pulse as it goes down and hits Art. Art's going to be a fixed end.
All my degree and everything is in really good.
So you can see that the pulse going down and hitting the fixed end does something interesting. It flips side. This sets up an interesting situation. We can send the pulse back and forth along this spring, and we can get it to resonate at different frequencies. And this system has a natural frequency here. This is the fundamental and we'll refer to that often later on. You can also get a neat pattern if you double the frequency. Now you notice whenever the waves reach middle, they totally cancel out. That's called a nodal point. And if you would, when you see good nodes like this on the next couple of notes, say nice nodes. You go up to 3 times the fundamental. What do you say? 3 times the frequency. It's all the same length. It's the same system.
I want to point out too that when he starts the motion, you can actually see the motional waves start out, and then when they get bouncing around, then you get.
This almost doesn't need any explanation, does it?
No, it's You look at the tube and it has a number on it. Read the number. And here's how you work the palm pipe.
When your number is highlighted with a red arrow, then you hit your palm pipe with the appropriate number once.
Ready?
1 ping, please.
Ready and.